In our previous lectures, we understood how to find the time complexity of single loops. We learned a lot about finding the time complexity of single loops. Now from this lecture onwards, we will understand how to find the time complexity of nested loops. In this lecture precisely, we will understand how to find the time complexity of independent nested loops, which is one type of nested loop. So let's get started and let's see the topics of this lecture. The first topic of this lecture is nested loops introduction. After completion of this topic, we will then proceed with the example of independent nested loop to properly understand how to find the time complexity of such type of loops. Let's start with the first topic, nested loops introduction. So what is a nested loop? A nested loop is a loop in which at least one loop is within another loop. I have mentioned at least one because there can be more than one loops within another loop, but at least one loop must be there within another loop in order to say the entire structure is a nested loop structure. There are two types of nested loops. One is independent nested loop and the other one is dependent nested loop. We will currently focus on the independent nested loops and then we will understand dependent nested loops in subsequent lectures. The focus of this lecture is independent nested loop. So let's understand what is independent nested loop first. So what is independent nested loop? This type of loop is a nested loop in which inner loop variable is independent of the outer loop variable. This means the inner loop variable which belongs to the inner loop does not depend on the outer loop variable which belongs to the outer loop. In order to properly understand this statement, we will discuss one example pretty soon. But for now, just observe this definition and just remember this. As we now know what is independent nested loop, let's learn how to find the time complexity of independent nested loop. In order to find the time complexity of independent nested loop, we need to find the frequency count of each loop and multiply them. So time complexity of independent nested loop is same as multiplication of frequency count of each loop. Now we are ready to understand through an example how to find the time complexity of independent nested loop. So let's proceed and let's understand the example of independent nested loop. Here is the example. Let's say we have this for loop structure. Can we say this structure is a nested loop? We know the definition of a nested loop. A nested loop is a loop in which at least one loop is within another loop. Here we can observe this for loop is within this for loop as it is observed from the indentation. This loop is indented and hence we can consider it as part of this for loop. Therefore, this entire structure is the nested loop structure. Now can we say this nested loop is independent nested loop? According to the definition of the independent nested loop, it is a nested loop in which inner loop variable is independent of the outer loop variable. We can observe this for loop is the inner for loop and this for loop is the outer for loop. In the inner for loop, the loop variable is j. So this is the inner loop variable. And I is the outer loop variable because this loop variable belongs to the outer loop. Can we say j is independent of I? In these statements, we can observe variable I is not used. J is initialized to 1, not I. J is compared with n, not I. J is incremented by 1, not I. Clearly, j is not dependent on the variable I. Therefore, j is independent of I, and hence this nested loop is independent nested loop. Now we know this loop is the independent nested loop. But how do we find the time complexity of this loop? Our job is to find the time complexity of this independent nested loop. How to do this? There are two ways to find the time complexity of an independent nested loop. One way is to find the frequency count of the inner loop first, and then after this, we can find the frequency count of the entire loop or the nested loop. This will give us the time complexity of the independent nested loop. And the second way is to multiply the frequency count of each loop, which we will learn later. Let's use the way number 1. Let's try to find the frequency count of the inner loop first. This inner loop is a single loop. As this loop does not have another loop within it, there is only one statement in this for loop, which is x equal to x plus 1. So this inner loop is the single loop. We know already how to find the frequency count of the single loop. The frequency count of a single loop is same as the number of times the loop runs. We need to analyze each iteration of the loop, and in each iteration we need to observe the values of the loop variable. The loop variable in this for loop is j. Let's analyze the values of j in each iteration. In the first iteration, the value of j is 1. In the second iteration, it will be 2 because j is incremented by 1. In the third iteration, it will be 3. In the fourth iteration, it will be 4. And this will continue up to the value n. In the nth iteration, the value of j will be n. This is the last value of j for which this condition is true. So j will receive values from 1 to n. The last iteration is the nth iteration. Hence, the total number of iterations of this for loop is n. And therefore, this loop will run n times. Hence, the frequency count of this for loop is n. Now we know what's the frequency count of this inner loop. Let's find the frequency count of this independent nested loop. In order to find the frequency count of this independent nested loop, we need to determine how many times this entire loop will execute. For this, we need to analyze each iteration of this outer for loop, and in each iteration we need to observe for different values of I how the inner loop behaves. Let's do this now. In the first iteration, the value of I is 1. Then 1 is compared with n. Let's say 1 is less than n. Therefore, the condition is satisfied. We know after the condition is satisfied, the statements within for loop will execute. In this for loop, we have this for loop. So this for loop will execute. And we know this for loop will execute n times. Therefore, we can say for I equal to 1, this for loop will execute n times. Or we can say variable j will receive values from 1 to n. So for I equal to 1, j will receive values from 1 to n. After completion of this for loop, I is incremented by 1, I becomes 2. Then 2 is compared with n. Is 2 less than n? Let's say 2 is less than n. The condition is satisfied. Therefore, this loop will run once again. And this loop will run n times. This means j will receive values from 1 to n. So clearly for I equal to 2 also, j will receive values from 1 to n. Similarly, for I equal to 3, j will receive values from 1 to n. And this process will continue up to I equal to n. And for this value of I also, j will receive values from 1 to n. So it is clear for each value of I, this for loop will run n times. And there are a total of n values of I. This means this entire loop will run n into n times. We just need to add n times. And this means we need to multiply n by n, because n added n times to itself is same as n multiplied to n. Hence, this entire loop will run n into n times or n square times. So clearly the frequency count of this loop is n square, and hence the time complexity of this nested loop or this independent nested loop is theta of n square. For each iteration of the outer loop, the inner loop execute n times, and as we know there are n iterations of the outer loop, therefore the entire loop will run n into n times. This is way number 1, and this is bit complicated. But there is one more way in which we can find the time complexity of these type of loops. And the second way is very simple. We learned this already, that in order to find the time complexity of independent nested loops, we need to multiply the frequency count of each loop. So we just need to know the frequency count of each loop, and then we need to multiply them. That's it. This will give us the frequency count of the entire loop, and this is same as the time complexity of independent nested loop. We know this is the independent nested loop. The frequency count of this outer loop is n, because this loop will run n times. As we can observe, the initial value of I is 1, I is compared with n, and I is incremented by 1 every time. So I will receive values from 1 to n. There are a total of n iterations, and hence this loop will run n times. Therefore, the frequency count of this loop is n. What is the frequency count of the inner loop? The frequency count of the inner loop, as calculated earlier, is n as well. This loop will also run n times. So we now know the frequency count of these two loops. We now need to multiply these two values. We need to multiply n by n. This will give us n square. So we got the multiplication of frequency count of each loop, and this is same as the time complexity of independent nested loop. This is the independent nested loop, and after multiplication we are getting n square. So the time complexity of this independent nested loop is theta of n square. So from way number 2 also we are getting the same time complexity. And I have mentioned theta here because this n square represents the lower bound and the upper bound of this entire loop. Why? Because this independent nested loop will execute at least n square times. Therefore, this is the lower bound of this loop. And also, this is the upper bound of this loop. So the worst case performance of this loop is also n square. So n square represents the lower bound and the upper bound, and hence n square is representing the best case performance and the worst case performance of this independent nested loop. This is the reason I have mentioned theta here. We can write big O also. Then in that case, we are saying the upper bound of this independent nested loop is n square. We can also mention big omega here. This will represent the lower bound of the independent nested loop. N square will be the lower bound. In place of writing big O and big omega, I have mentioned theta, as n square is representing both the lower bound and the upper bound of this loop. So now we know what's the time complexity. The time complexity is theta of n square. So with this, we are done with this example. We learned how to find the time complexity of the independent nested loop. Now we are done with this lecture. Okay friends, this is it for now. Thank you for watching this lecture. I will see you in the next one.